on Google Cloud to, getting started on your application development journey. So we'll be covering a little bit about that, and we'll also be looking at a demo, which can help you get started really, really quickly. So without further ado, let's get into it. So, so Google Cloud provides an end-to-end solution for application development and delivery, right? When we look at application development, we really come from the thought process of how did we get started, or how do we get started whenever we're trying to create a service that we're going to share with the outside world, and people are going to use it, and expecting billions and billions of people around the world to use it. So essentially, the same technology, the same platforms, the same frameworks that we use to develop our tools to share with the world is what we make available in Google Cloud as well. On a 10,000 feet level, this is a snapshot of what all is available on Google Cloud. Like I said, on a 10,000 feet level, the idea is very simple. We provide programs that help customers, and this is primarily for customers. We provide programs that help customers kind of analyze their applications and figure out how to modernize them, how to go about it, to collect the right data, and which direction to go in the sense of application modernization, whether they should rehost and replatform or rewrite, so on and so forth. That kind of a direction. The next is when you have decided to kind of code your application and you want to start developing your code really quickly, what tools are available, from coding the application itself, debugging, testing, so on and so forth. Building the application into containers or container native formats that can then be packaged and run on multiple different frameworks, whether it be Kubernetes, whether it be something known as Cloud Run, which is a serverless capability at Google, so on and so forth. So multiple different options, from the maximum amount of hands-on required in infrastructure management to the lowest amount of hands-on required in the sense of infrastructure management. So multiple different run options, and then obviously operational and site reliability engineering level options, which kind of help you look at holistically how your application is doing, how your business metrics are doing, so on and so forth. At any point in time, if there are any questions, please feel free to put them in the chat. I have the chat open in front of me, so I'll be able to address them right away as well. So where do I start? I'm looking to develop some applications, do some code. Where do I go? How do I start? Cloud Code is basically an IDE plugin that automates your development workflow for cloud native applications. It's a plugin that you can install in a bunch of different IDEs of your choice, whether it be IntelliJ, whether it be VS Studio Code, Visual Studio Code, or JetBrains IDEs. But having said all of that, Cloud Code is also available in Google Cloud. So you could essentially use Google Cloud as a development environment for yourself without needing to set up the entire thing on your desktop or your machine manually. So typically one would install an IDE like a Visual Studio Code on their own machine and start hacking away there, right? What if I told you that you don't need to do any of this? On the code itself, you can write down your code, you can compile it, you can debug it, you can run it, you can test it. So now even if you have something like, a Chromebook or a very, very lightweight netbook kind of a laptop, you can still develop the most extreme, most extensive kind of code that you want to. And Cloud Code helps you do that. It helps you ramp up fast. So it comes with a bunch of integrated capabilities that allow you to quickly deploy and debug on various different sources, whether it's locally within the cloud environment itself, or to deploy to a target runtime, which could be a Cloud Run or a Kubernetes, so on and so forth. It allows you to build, push, and deploy your code as well to any of these runtimes across multiple dimensions. And it allows you to redeploy your changes constantly. So in the sense of software development, live reload is something that's very, very helpful. It cuts down a lot of time that we as developers spend in kind of going around and deploying and then going back and changing and then deploying again. So it's got live reload capabilities as well on the cloud, and it helps you discover cloud APIs also really quickly. This is a very good positive point. If you're looking at it from a hackathon perspective, if you're quickly running to put some code together, hack something together, punch out an idea, discovering the right cloud APIs could also be something that takes a lot of time and effort. With Cloud Code, you're able to do that right in your IDE environment. Excuse me. So now that I've got my code, and I'll be showing a demonstration of all of these different things. Now that I've got my code, I've written my code down and I want to package it. I want to package it for distribution. I want to package it to run it on a particular runtime of my choice. How do I do that? How I do that is with a bunch of CI/CD tools that are available in Google Cloud directly. There is a tool called Cloud Build, which is for the purpose of continuous integration. And then there is a tool called Cloud Deploy, which is for the purpose of continuous delivery. With Cloud Build, you're able to give your source, which is your source code essentially, and build in place, right? So you can direct Cloud Build to pick up your code automatically, understand what language it's written in, and there's a bunch of different languages supported. It will automatically look at the code, understand what language it's written in, and then containerize it for you automatically using best practices. So you don't even have to go through the effort of writing a Docker file yourself. It can automatically pick up your code, understand the source, and build it for you. Cloud Deploy is a tool that allows you to deploy to multiple different environments on Kubernetes. So in typical developer parity, you have typically 3, 4, 5 environments. Cloud Deploy essentially allows you to create multiple different environment targets where you can deploy to, whether it's an on-premise cluster, whether it's a GCP cluster or what have you, multiple different targets, and then it allows you to use approval workflows to kind of deploy to all of these targets. By the way, these tools are built on top of open source technologies. There is a CI/CD tool called Trecton, and Cloud Build is also built on top of Trecton. So if you know how to use Trecton, you're on a good path to using Cloud Build. Once I've created my image automatically or manually, however it is, I would like to store my image somewhere. And if you've done something like software development with Node.js, for example, then you would be well aware of the kind of dependencies that are required within Node.js, the sheer number of node modules you end up accumulating over time. And more importantly, how often these node modules deprecate themselves. Okay, so if you've ever worked with Node.js, it's one of those recurring problems. Your code will build today, but 6 months down the line, if you try to download those dependencies again, more often than not, it doesn't work. Okay, the enterprise solution to getting around that problem is to actually store those dependencies somewhere, whether they're Node dependencies or Java dependencies or Python dependencies, right? Or their APT, OS level dependencies, so on and so forth. So artifact registry is a natural progression to Google's container registry, which has been around for quite some time. Google Container Registry is the registry where a lot of Google's own products are also distributed, including a bunch of different open source technologies, open source platforms that are developed are also distributed. In fact, even the open source Kubernetes project is distributed. The images for the open source Kubernetes project are distributed on Google Container Registry. Artifact Registry is, so to say, a newer version of that, with enhanced capabilities around encryption, around permission management, around automatic scanning, etc. So it allows you to control access to all of these artifacts, whether they're your different modules or their container images. It allows you to store them regionally, that is in one region, or across multiple different regions, in case the consumers for those images or artifacts are going to be across multiple regions. And it is pre-integrated with Google Cloud container-based services. So you use the URL for the artifact registry image or the resource, and it will automatically get picked up by your services on Google Cloud. Net, this is the kind of workflow that we're essentially talking about. Cloud Code allows you to code your application. There is a cloud source repository available in Google Cloud as well, which is essentially a Git repository where you can store all your code. With advanced access, etc. permissions and capabilities. So it's a Git repository of sorts that you're able to store all your code inside. From this, you're automatically able to pick up your code every time there is a new push to your Git repository, and use the CI tool, which is Cloud Build, to pick up your code, build it automatically, create container images for you, and then push those container images to Artifact Registry. You push your images to Artifact Registry, and this is where you can store them. Your image building also happens in the cloud. So the good thing about that is that you don't need developer heavy machines. You don't need a 16 GB RAM machine, for example, to build your container images for a Java application, for example. A lot of times, building your code into a package consumes a lot of memory. What if you could do that on the cloud as well? So cloud build kind of answers that question and allows you to build your code on the cloud itself. So with cloud build, you're able to build your code, push it to a storage location, which is artifact registry in this case. And you can also use cloud build to trigger a deploy function or a deploy pipeline, so to say. This deploy pipeline will deploy to a target of your choice, which could be amongst multiple different Kubernetes clusters. The target is a different choice of multiple different endpoints where you can deploy your services, whether it is Google Anthos for multi-cloud or hybrid cloud, however you like it, or Cloud Run, which is a complete serverless offering, uh, or Kubernetes Engine, or Cloud Functions, or Firebase, right? So a bunch of different options where you can deploy your code to. And then on top of this, we're automatically able to provide you cloud logging and monitoring pre-integrated with all of these solutions. I'd like to repeat again, if there are any questions, please feel free to put them in the chat, and I can read them right away and answer them as well. The final question is, okay, I've got my code, I've built it, I put it into artifact registry. Where do I run it? How do I run it? Google Kubernetes Engine is a very interesting piece of the infrastructure as service capabilities that we provide at Google Cloud. Google Kubernetes Engine, as I'm sure everybody must be aware, Kubernetes was created at Google. So Google Kubernetes Engine provides the best Kubernetes experience on the planet, period. The reason for that is that even as newer and newer features are created, developed, and tested, all of that is actually done on Google Cloud. Okay. And because of our extensive experience of running Kubernetes internally within Google to power, Google Drive, Google Search, Google Mail, so on and so forth services, we are able to provide a managed offering which is known as Google Kubernetes Engine. Being on the edge of Kubernetes utilization, in fact, we boast about 15,000 node scalability also, which is far beyond what any other managed Kubernetes provider can do. And a bunch of different features, which are again industry leading in their own sense, whether it is auto-scaling not just your workloads on Kubernetes, but also auto-scaling your Kubernetes environments completely, automatically repairing them, patching them, upgrading them, and essentially giving you 4 different dimensions to scale your Kubernetes clusters by. That's a differentiating, groundbreaking feature. Using 4 different dimensions to scale your clusters with is not something that anybody else is able to give in the world today. You can also integrate your Google Kubernetes engine with world-class GPUs and TPUs. If you want to run your machine learning algorithms in a distributed manner on, say, a Kubernetes cluster, you can have Kubernetes nodes, which are actually GPU powered or tensor processing unit powered nodes, which can essentially allow you to run machine learning in a distributed manner on Kubernetes. And then obviously there are a bunch of different security features. By the way, there is a particular link available online as well, which will show you that there are 76 different configuration options available with Google Kubernetes Engine, almost twice the number of configurations available with the next best managed Kubernetes cloud provider, right? So there is a question in the chat: is auto upgrade beneficial when running a container when running in a container like Kubernetes? Okay, so Kubernetes is a container orchestration engine, not a container itself. So let me understand the crux of the question. Is auto upgrade beneficial? Yes, auto upgrade is beneficial because there are a bunch of security issues, features, bug fixes, advancements in technologies that come every now and then, right? And while as developers, we would like our environments not to keep changing, right, constantly. We as developers would say, if it's working, let it be the way it is. Let it work. Don't touch something that's already working. Don't break anything that's already working. So from that perspective, we are right to say that. But then there are other operational aspects of running something in an enterprise environment as well. And those are things like security. Those are things like staying in compliance with the latest version so you get the latest security updates. Right. For example, if you hadn't upgraded your Windows, maybe it would be vulnerable to a bunch of different bugs, which because you upgraded are not which you're not vulnerable to today. So auto upgrade is actually an industrial requirement. It is a requirement that we're trying to serve to people who are also running like hundreds and thousands of clusters in their organization. Doing it yourself for one or two clusters is fairly simple, but when you have to do it at scale, it becomes a very big problem. By the way, within auto upgrades as well, there is the option to create exclusion windows, something known as exclusion windows. So if you're running a program which needs to run the way it is till say Diwali or say Black Friday sale or something, you can actually create an exclusion window and say that, hey, till this period, do not upgrade my cluster, or from Monday to Saturday, do not upgrade my cluster. Right. So you can actually create those kind of exclusion windows also, which is again something very, very unique to us. If there, I saw somebody raising their hand. If there are any questions, please feel free to put them in the chat. The next option for a runtime after Google Kubernetes Engine is something known as Cloud Run. Cloud Run is basically a serverless offering where you can just throw your code. Essentially, you can run your code and deploy in seconds to a container, and it will automatically give you HTTPS, SSL, and you can connect your own custom domains to it as well. Right. And Cloud Run only charges you for the duration of your request. Okay. So unlike a Kubernetes engine or compute instance VM that you would be running, they are not serverless. So therefore, once you provision it, you will pay for the entire duration that the component is running for. In the case of Cloud Run, it is completely serverless. So therefore, you will only pay for the number of seconds per request that your platform is taking. Okay, it can handle multiple, extremely high concurrency also, and it's been used by multiple customers in production-ready systems. And essentially, Cloud Run is a serverless offering based on, again, an open source technology. So at Google, we are extremely committed to using open source technologies and providing them with the right support and the capabilities that organizations would require, and not just from a fund development perspective. So Cloud Run is based on a technology known as Knative. Knative is a platform that gives you the capabilities to run serverless on Kubernetes. So we've made Cloud Run available as a serverless platform on Google Cloud as well. You can essentially just throw your code at it, one single command saying gcloud run for me XYZ code, and it will automatically pick up your code. If there is a Docker file, build it automatically. If there is no Docker file, it will automatically containerize your code and then run it on a serverless target for you. What is the benefit? It's completely portable. You can bring in any language, any library that is containerizable. If you can put your code inside a container, if it's a language that you can put inside a container, you can run it on Cloud Run. We don't impose any limitations on what you can run in Cloud Run in that regard. Portability. Let's say if you want to be able to do this on premise as well, so you can actually create a Kubernetes cluster on premise, install Knative on it, and try whatever you're doing on premises as well, or on your local laptop as well before you deploy to Cloud Run. Having said that, you can do all of this on Google Cloud also, the development pieces, without paying for it. And there is no cluster management. It's a serverless service, so you don't have to manage upgrades, patches, security, bugs, fixes, nothing. All of that happens automatically. Not just that, there are multiple different ways to trigger a Cloud Run function. So you can actually use something like an Apigee or a Cloud Pub Sub, or a multitude of different platforms, or simple REST. If you want just HTTP or HTTPS endpoints, you can use simple REST. As you can see the URL over here, you can use simple REST to just invoke your functions as well. And you can link it to your CI/CD pipelines as well. And I will show you that in the demo that follows. But you're able to link Cloud Run to your CI/CD workflows as well, and automatically deploy a new Cloud Run function every time Cloud runs service. Every time there is a new push to your code, to your Git repository. Then there are Cloud Functions. As the name suggests, these are functions. The idea is to have extremely small functions, typically used as glue between multiple things. So if you want to, for example, create an infrastructure component and then deploy to it, and at the time of creating the infrastructure component, you want to do certain things like making a database entry, or throwing something out to a UI, something like that. For those abstract things which can be run in a function itself, in one single function, in the regular sense of coding, then Cloud Functions is a very good logical choice for it. It's been around for a very, very long time. So it's a battle tested service. Like it says over here, it's for single purpose reusable code, right? So if there's a simple piece of code that you want to reuse everywhere, just a simple function that takes some text and puts it into a PDF, maybe you could use Cloud Functions for that. Or a single piece of code that picks up a file that is put into object storage and does something with it, like a Word file that's put into object storage. You want to pick it up, and every time there's a new file, you want to pick it up, convert it into a PDF, and send an email. For something like that, you could use something like Cloud Functions, which will automatically be able to read, object storage APIs and do all these kind of things. It's got a bunch of it is triggered by an event. So essentially, any event that is generated on Google Cloud, and there are a bunch of different events which can be triggered from logs itself. So every time there is a event that is triggered, you would actually invoke a Cloud Function from that and do something as well. It factors in for automatic replies and supports a bunch of different languages like Node.js, Python, Java, PHP, Ruby, .NET, so on and so forth. And like I said earlier, Cloud Functions act like a glue that connects all Google Cloud services. So essentially, if you're looking for, hey, how do I connect? How do I do it from my cloud storage? I want to trigger some code running on a virtual machine whenever something happens in cloud storage. Do I need to necessarily create the API in my code to kind of listen to my object storage and do something with it? You don't have to. You can create cloud functions which will run completely serverlessly. Every time there's an event of something writing to a storage, it will trigger and then it will publish this to somewhere else. You could either call a compute service or you could put it on a Kafka-like pub sub service, and your code can just listen to that. So it's another way to kind of decouple your code and run it in a more event-driven kind of a fashion. And then there is App Engine. App Engine is a web framework that supports routes and HTTP methods, which basically means that it is one of the older, offerings. Came back. I think it was released somewhere around 2008, 2007, and it is a serverless offering again, which allows you to basically throw your code, at it, and it will bring in all the other 12-factor components required around it: the monitoring, the configuration, the security pieces, the automatic building, all that automation. It will bring all of that automatically. This is essentially for applications where you want to, let's say, you want to create an entire web application, and you want to break it down into different pieces, and you want to host it somewhere. You can throw all of those pieces of code at App Engine. App Engine in a single project will show you this, orchestration of different services, and you're able to do canary updates. You're able to do rolling updates. You're able to do blue-green deployments, so on and so forth. And you're also able to bring in your own custom domains. So from an application building perspective, App Engine works like a serverless platform that allows you to look at it from a complete application perspective, right? So if you want to do simple functions, just one simple function that does one reusable task, then use Cloud Functions. If you want to do a bunch of operations like maybe a simple microservice, then look at something known as something like Cloud Run. If you want to build an entire application like microservices, based application which is decomposed into multiple different microservices, but you don't want to worry about the entire operational aspect like logging, monitoring, so on and so forth, then look at App Engine. And if you want to manage the entire infrastructure, you want to have finer grain control into how your containers are running, then maybe look at Google Kubernetes Engine. This is an example of a setup that, for example, a customer has, EcoB. It's a GCP services architecture wherein there is a customer-facing web and mobile client app. It integrates with EcoB's end-user authentication authorization system, calls a GraphQL gateway, which then triggers your services running on Cloud Run. So the entire backend can be on Cloud Run, multiple bunch of services which are individual functions, where you want extensive scalability. Let's say, for example, there is a search capability that you require, and you don't know how many searches people are going to do, or you do know that within the 12 hours of the day you get a lot of hits, but during the night time you don't get as many hits because maybe your service is regional in nature, and that's fine. So you don't want to pay for the extra cost of running your infrastructure continuously. So you could deploy certain capabilities, like maybe a search capability on Cloud Run. But there are certain things which maintain, which you want to have running at all times. There are certain things like, for example, the list of invoices, because your admin backend and your customer front end both use a list of, let's say, the invoicing module, like what are the invoices that have been sent out, or the inventory module, like what is the inventory available internally, right? So those kind of services can be used, can be put on something like a Google Kubernetes engine. Okay, and you can connect it to multiple different databases. Like you've got Firestore over here, but you can connect them to SQL databases as well. And you can also use, you can also trigger out messages from either of these to PubSub, okay, which is Cloud PubSub, and then based on PubSub incoming messages, you can actually take actions. So it's a mixture of HTTP REST and gRPC, PubSub events and analytics. And if you have some services which are unmigrated, which are not ready to be run on Cloud Run, but you can containerize them, maybe that's one more case where where you can look at GKE. There is another question in the chat which says, does Cloud Run provide gRPC support, or should the backend support them explicitly? I mean, is gRPC optional? Yes, gRPC is optional. So if you want to use gRPC, if you want to use the protocol buffers, and that is how you want things to communicate, maybe external customers, or typically what happens is that in a lot of scenarios, people use gRPC for internal communication and not for external clients. So external clients like the mobile app or the web front end would still use HTTP or REST, and the services that are talking internally can go ahead and use gRPC. Cloud Run supports both, so you can have invocations coming in from REST as well as gRPC. Um, Another way to look at the different use cases for different compute capabilities is this table. So if you want to run HTTP, if you want to run an HTTP web application, you could actually run it on top of App Engine if you're looking at it from a complete application perspective. And from the perspective of the hackathon, for example, if you're going to have a bunch of different people working together, then App Engine could make a lot of sense. You create one project, and that project is equivalent to your application that you're going to demonstrate eventually, right? And everybody can create a bunch of different services within that application. And this logical hierarchical structure, while still having the operational components common, is something that you can get from an App Engine. You could do that in Cloud Run also. You can do that. You can get Cloud Run functions or Cloud Run services to talk to each other across multiple projects and so on and so forth also. And you can run an HTTP web application on Cloud Run technically as well, right? You could use App Engine and Cloud Run both to power both web and mobile backends. You can use it for both internal APIs and services as well. For data processing, we recommend using Cloud Run over App Engine. Sorry, my bad. For data processing workloads, for example, if you've got a stream of data coming in and you want something to pick up that data midway, transform it, and then push it into a database or push it to a compute runtime of your choice, Cloud Run is also a component which is used in this kind of cases. If you're looking for more automation like event-driven reactive automation, then Cloud Run, Cloud Functions are typically the options to go with. And if you're looking for application integration services, for example, like I said, from something that is dumped into your storage, you want to call a compute engine VM or something that's running on a compute engine VM. For those kind of use cases, you could use something like Cloud Functions or Cloud Run, and maybe an entire app engine service would be an overkill. There's another question in the chat which says, during the hackathon, do we need to ideally use as many services possible out of the one listed? Let me answer that slightly differently. During the hackathon, the idea is to show innovative, showing whatever you're creating as innovatively as possible. It does not necessarily imply that you need to make life extremely difficult by using a bunch of different services where they're not required. So the reason why I am running this session particularly is to show you the gamut of different services that are available. However, you can go ahead and pick and choose whatever different services for whatever different use cases you want to use. Okay. The idea would be to show some amount of automation, to show some amount of outcome that you're able to see in the monitoring, logging, etc., and how you can make sense of that. That would be plus points. So effective utilization of different services available on Google Cloud would be a positive factor. Yes. If you want a complete lowdown, because you're going to be working on a bunch of different services, and and you're going to be choosing amongst all of these different services to create your code. There's actually a link which is called hosting options, cloud.google.com/hosting options, which delves deeper into this topic of which service to use for what kind of a thing. And it's got this table is from the same website. It's got this list of entire services and what they're good at doing and what you should probably not do with them. And also you've got links on the left hand side, so all of these different links that you can use. This is something to look at. However, I would take this opportunity. I would want to take this opportunity to point you out to one more thing. A lot of these services, whether it's Compute Engine, whether it's GKE, whether it's Cloud Run for Anthos, or Cloud Run without Anthos, or App Engine, or Cloud Functions. There is, by the way, a newer version of Cloud Functions available, which is Cloud version V2, which uses the same backend as Cloud Run. Okay, so it's got more enhanced capabilities. So if you're looking at using Cloud Functions, look for Cloud version Functions version 2. Okay, for backward compatibility reasons, we still have version 1 available today for people to use, but the newer features are available in Cloud Functions version 2. So coming back to the point that I was trying to make, one of the key points about using Google Cloud is the flexibility of using from one service, moving from one service to the other. Multiple other cloud providers are not able to give that flexibility of being able to move seamlessly from, say, a Kubernetes distribution to a serverless offering, without making some code changes or without making some changes to the way the code talks to the underlying infrastructure or to other cloud services. With Google Cloud, we're able to do that, and that is one of the differentiating factors. So feel free at any point, if if you get stuck with one service or you feel like one service is not cutting the deal for you, all of these services can run well with containers. So if you're able to containerize your app using Cloud Build, like I suggested earlier, or yourself, you can actually move around containers amongst any of these services, right? So if you feel like you're losing control or Kubernetes is feeling like it's just too complicated, you containerize your application, you can throw it at Cloud Run, right? Or you can just go to Compute Engine, and even on the Compute Engine page, there is an option to create a compute VM from a container as well, right? So you want to create an entire container just to serve the purpose of a virtual machine. You want to create an entire virtual machine just to run that one container inside it. You can actually do that on Compute Engine as well, okay? Without having to manually go install Docker and then run your container inside that, etc., etc. So you don't have to do that. And this is a differentiating factor for Google Cloud, by the way. The ability to freely move between different services just because you've containerized your code. It's a key differentiator. Now we can see some of this in action, and I thought that because we're working on we're working on a hackathon, it makes sense to see something that can be done quickly, right? How do you get started? Okay, so I'm gonna share a bunch of tips and tricks that are available on Google Cloud. Okay, I'm gonna change my project. Please feel free to put any questions in the chat. I can still see the chat in parallel and I can keep answering questions. So what are we going to be doing today as a part of the demo? Yes, because the video is being recorded and it will be shared. So what are we going to be doing today? We're going to start with creating a new application from scratch. Okay. And then we're going to look at how we can build it and then deploy it to Cloud Run, and how we can automate it as well. Okay. So let's get started. So this is your GCP console. When you come to your GCP homepage, this is what you see after logging in. On the top right corner is the button for Cloud Shell. So I click the button for Cloud Shell, and Cloud Shell is a free of cost. Yes, from a development perspective, it's a free of cost environment available to you to develop your code. Okay. So inside my Cloud Shell, I don't pay anything for Cloud Shell. Okay. Now let's say I want to go to my directory and sorry. Yeah, let's go here only. Okay, so I'm in an empty directory called experiment. Okay, now there is an IDE available inside Google Cloud as well. Okay, again, free to use. So I just clicked on the button which said open editor, and that opens up. I'm using an incognito window. Sorry, sharing the wrong screen. So I am using an incognito window, right? Which is why I got an error when trying to open it there. But if you're using it in a normal browser, you click open editor and it'll open up an editorial window for you Let me show you what that looks like. This is what it looks like. Does this look familiar? This looks a lot like VS Code, doesn't it? Okay. So you're able to get an IDE environment completely on the cloud itself for you to work on, and you don't pay anything for this either. So I can go ahead and select my workspace. I say open the workspace, and I go to trials, and I go to experiment, and I open my workspace. This UI is something known as Thea, which is like a branch of from Visual Studio Code, and hence the similarities. The things you see on the left hand side for debugging and the individual things like cloud code, you can see the alternate name says cloud code. Oh, you can't see. Okay. Um, these are all cloud code extensions which are installed automatically inside this ID by default. So what I can do now is I'm inside my coding environment. I click on the cloud code button on the bottom. This is the extension that you can install to your IDE on your local machine as well. And I say I want to create a new application. It will ask me what kind of application do I want to create. Do I want to create a Kubernetes application or a Cloud Run application or a custom application? Let's say I want to create a Cloud Run application. It's going to give me a few quick start options. Do I want a Python Flask or a Python Django, a Go, a Node.js, Java, or a .NET application? Let's say I select Node.js. So it's going to ask me where do I want to create my application. I want to create my application right here. And this will download the code for me automatically and open up the workspace. Now this is a local development environment. So what we do is we persist the disk, okay, and delete the or stop the shell instance that you see. So the shell that you saw in the previous screen is actually running inside a container, and all this data that you're storing, all this repository that we pulled in, or the sample code, it is on a persistent disk. So the persistent disk stays separately, and we persist it for you, and you don't have to pay for it. The compute instance goes away. Every time you come and you click on Cloud Shell, it creates that container all over again. Okay. What that means is that you can actually customize the shell for what you want as well. So if there are certain shell extensions that you like to use or certain tools that you want to install in your shell, you can actually use a custom container image for your shell as well. Okay. Now this is the demo code that it came with. This demo code that I was able to create really quickly. As you can see, it's got the index.js, the world famous index.js file in Node.js. It comes with some pre-populated code. I can obviously freely remove as much of this as I like. It's using the handlebars templating engine, and if I don't want it, I can remove it. Right, so that's completely my call. This is some sample code, and it comes with a Docker file as well. So there is a Docker file that's coming out of the box. If I want to change something about the Docker file, I can freely do that. Now let's say this is my code for the sake of demonstration, and I want to debug this code, or I want to run this code locally like I would on my browser or on my machine without paying for it. How do I do it? I click on Cloud Code again on the bottom left corner, okay? And then I say run on Cloud Run emulator, okay? And this is going to create an emulator environment inside my browser for me. The way it does that is that it installs Minikube inside this development environment. And because Cloud Run is based on a serverless technology, which is Knative, we run Knative on top of that Minikube cluster, which is running locally. Okay. So with this, I'm able to debug my code locally. Okay. This may take a couple of minutes because it's starting Minikube from scratch. At the end, it will give me a local host URL where my application is running. And in Cloud Code, my port 8080 is exposed. Excuse me. In Cloud Shell, in Google Cloud Shell, my port 8080 is exposed externally as well. So I can just open it and view that as well. So while this loads, we can actually go back and look at putting our code into a repository. Okay. So I've gone here and my code is, let me try and increase the size a little bit. Okay. So now I'm here. My code is in hello world, cd hello world. Now I want to create a new repository to push this code into. So there is something known as code, source repository on Google Cloud, and I can go to that source repository. And here you can see there is no source repository in my project right now. Karan Kapoor, K Kapoor demo, there is no source repository here. So I can go back to my environment and I can check my code and I can create a Git source repository for my code. Okay. So I open up my tab where my code is. I go here and I say gcloud source repository repos create hello world. So I'm saying, hey gcloud, create a source repository for me called hello world. Okay. So it has created a repository for me called hello world. Let's say I want to get the URL for this. So I say gcloud source repos describe hello world. And this is the URL for my code repository. I'm going to copy this. Okay. And now I want to initiate this directory. I've got my code here in this directory. And I want to initiate my repository here. So I say git init. This Cloud Shell, by the way, comes with all the tools that you would require to do your regular day-to-day coding. It's got Python also installed in it, but if you want to change the version, feel free to obviously. So I say git initiate, and I create a new repository for me, a git repo for me. I say git remote add Google. I'm adding a remote location, which is the source repository that I just created. Okay. And I say git add, I want to add my code to it. And I say git commit, initial commit. I check my branch. I'm in the main branch. I say git push Google main. Simple. With this, I was able to create a repository and push my code right into it in a couple of minutes. Okay. Now, if I quickly go back to the tab where we were trying to deploy the code and we were waiting for Minikube to run, this was my development environment. You can see really quickly that my code has been deployed and it is available at localhost 8080. So I can actually click on this and it opens in a new tab for me. And you can see that the application is deployed over here. Okay. Let me share the entire window instead. Okay. So now you can see my entire window. So this is where I'm locally running my code. You can see it says it's got a funny URL, which is in my cloud shell.dev. And you can see this created the revision local of the Cloud Run service hello world. Okay. This is my development environment, and this is my Cloud Shell where I pushed my code from. And if I go to my source repository, then I can actually go back to my source, and there is a repository in Kikapu demo now created called hello world. I can go back to the main branch, and you can see over here it created the repository for me with the name initial commit. So I've got my code in one single place. Okay. Now I want to use a tool called Cloud Build to automate the deployment to my Cloud Run service. Okay, on Google Cloud. So what can I do? I can actually copy a simple file that I had created. Just a second. So I'm, for the sake of ease, I'm copying this file here, but it's actually a fairly simple file. If I show it to you, this is the cloud build file, the cloud build.yaml file. I can actually stop this debugger right now. I go to debug on the left-hand side and I can stop my debugger. Okay. And you're going to clean up for me and turn it off. Okay. Now this is the cloud build file that I've created. It's a very simple YAML file, which basically says, I want to use the command gcloud. I want to say gcloud run, basically saying cloud run, deploy a function called test. Let me change the name of this to hello world. Okay. The source is the local directory. I can either do this, or if I specify a Docker file, it will use the Docker file. I can use the region. I'm saying region US Central 1 in a managed platform, and I want to allow unauthenticated users to be able to access my file as well. I can run this same command directly in my code right here and it'll deploy to Cloud Run. But I want to automate it. I want to push a new copy every time I'm deploying. So all I need to do is now that I've added this file, all I need to do is add it to my code, git commit. I want to add it to my code repository. Git push global main. I see a question in the chat. Give me a minute. I'll come back to it. Snesh, if you could put the question in the chat, that would be great. Or give me a couple of minutes and we'll come back to it. So now I've pushed this code into my repository. Okay. And I want to create an automatic build pipeline. So I go to cloud build. Okay. Cloud build is a leading CI/CD tool in Google Cloud, which can help you do continuous integration and delivery as well. Now I want to create a trigger. I want to create a pipeline trigger which will deploy my code to Cloud Run every time there's a new release of my code. Okay. So I say create a trigger. What do I want to call my trigger? Hello world, let's say. When do I want to run it? When there is a push to a branch, or in response to manual invocation, blah, blah, blah. So I've got a bunch of different options here. Let's say I want to do it for pushing to a branch right now. I choose my repository, which is the hello world repository we created. I choose the branch, which is main branch. I don't need to change any of this. If I want to, I can, but I don't have to. Okay. And I'm saying that my cloud build is right here. And then I say create. Okay, so Vikas's question, for production-ready web apps, does GCP provide DNS services, hosting services, SSL certificate services? Yes. So for production, yes, GCP does provide DNS services. We've got something known as Cloud DNS, which you can use to manage your DNS zone files. Hosting services, there are a bunch of different hosting options that we provided that I just showed. You could host your application on Compute Engine or on Kubernetes or Cloud Run or App Engine. You can host your services any of those places. There's another service which is available known as Firebase, which is very, very popular for making web and mobile apps. And our triggers supported in YAML file. I'm not sure what this question means. Our triggers supported in YAML files. If you're asking me what is the format of the file, then yeah, the cloud build file format is YAML. Yes. The trigger that was just created. Yeah, that's a YAML file. That's a YAML file. And yeah, so I've created my cloud build pipeline right here. Now, as you can see, I had something in my code which says it's running. Let me go ahead and change this. Okay. I'll go back to my code. I'll go to the HTML page and let me change it's running welcome. Okay, I save it and then I go back to my shell. I can do it from here as well. I can create a shell here as well, as you can see. So just like standard VS Code. I have a personal preference to using it here, but yeah, you can use that one as well. So I just say git add, git commit, changed welcome header, and I say git push Google main. And this has been pushed. Now, if I go to my history, you should see a build starting right now, and the build has started. Okay, so you can see that there is a build happening. This is basically building your uh, this is basically building your code and creating a Docker file and using the Docker file that's already supplied. But if there was no Docker file, it would automatically pick up the language as Node.js and build a container image for me. That's fine. In the command, I wrote source dot. If you look at the cloud build YAML file here, I said source dot. So because I did not specify a Docker file, it could have simply used my source and create a container image for me without me putting in a Docker file. But because I did give a Docker file, it is using the Docker file as a preference, right? And here you can see that my build step is completed and the service has been pushed to Cloud Run. And it's saying it's running, welcome, this is my new code. This created the revision hello world of the Cloud Run service hello world, right? And if I go to the UI console, I can actually see Cloud Run over here. You can see the service right here. You can see out of the box, it's giving you a bunch of different features, whether it be request latencies, request counts. All of these are metrics that are available to you out of the box. If you look at the YAML, there's the interesting piece. It's using open source Knative. So if you're used to Kubernetes, you should be able to identify this immediately. It's a Knative type service. Okay. So if you wanted to run this on-prem or in any other Google on any other Kubernetes cluster as well, you could simply use the same YAML to deploy a Knative type service to any cluster, essentially. You've got different permissions. This can help you control finer grain details like what service accounts and what it's allowed to use. Excuse me. And there's a bunch of features like triggering and binary authorization and does it require authentication or not, so on and so forth. Multiple revisions, for canary deployment and traffic splitting, so on and so forth. So all of these capabilities are available to you right out of the box, and you can essentially change this URL as well and give your own domain name. Vikas asks, can you show usage of pull request review process in the demo? I don't have a demo for that right now, Vikas, but in the documentation that is also available and that is a supported feature. Okay, so this is the demo for today. If I go back to the slides right now, I hope you could see my screen, but I know you can't see the presentation. So let me go back to the presentation. There is one more important thing as developers that I wanted to share with you today, and that is Firebase. Firebase is a platform of tools and cloud services that basically help solve three core problems. It helps you develop your applications faster, which means if you want to create full backends like something that has a database and push notifications and user storage and authentication services, everything already in place, you could use something like Firebase. Firebase internally uses Cloud Run as the compute runtime. You can use Cloud Run or Cloud Functions as the backend runtime. And a lot of people use Firebase, from the likes of Duolingo to whatnot. A lot of customers who use Firebase, and it's fairly popular. Each phase of the application lifecycle requires different set of tools, whether it's for development, running, or for engagement. And these are essentially the aspects that go inside a tool. Firebase is our attempt at giving you all of this in one single platform. So you get data plus authentication, backend compute, testing, release management, analytics, and all of these different messaging and all of these different features right out of the box with Firebase. So Firebase is another very cool place to start with. Plus, an application that has been created with Firebase has a simple UI to integrate with Google Ads, the Play Store, Google Cloud, so on and so forth. So you can get all these things that you would require in order to kind of run your application at scale and for production. You get all of these in one single place using Firebase. And using Firebase, you can also develop applications for iOS, Android, web, C, C++, and Unity. Harita, I see your question. Is Cloud Build and Cloud Run free of cost or pay per use? So Cloud Build and Cloud Run are pay per use. And Cloud Run has a quota that is available for free as well. There is a free usage quota available as well. This is the last bit, but I don't think I'll be delving into this now. It is about availability and there's a simple thing that we say here at Google. It's called error budgets. And this is a simple snippet of that. 99.9% availability also implies that 0.1% downtime or limited availability is actually acceptable. Right? If you flip the coin around, this is another way to look at it. Right? Which means that the 0.1% is the budget of time that you have to do all your tech maintenance and fixes. Okay, this is known as your error budget. But that's a story for another day. This is what site reliability engineering is all about. So that's all. So thank you, folks, for your time today. These are my credentials if you'd like to reach out to me or connect with me. I'd like to open the floor for questions now. And Snehashish, I know I'm sorry I've kept you waiting for a long time. You've had your hand up for a while. You could unmute yourself and ask any questions if you like. Okay, if you're not able to unmute yourself, Nilesh, Avinash, can we help unmute Snehashish?
I have opened it up, so just one moment. Whom do you want me to unmute, Karan?
Snehashish.
Snehashish.
Yes.
Snehashish, can you try unmuting yourself, because I've given the rights for everyone to unmute and ask the questions.
While we do this, if anybody else has any more questions, please feel free to raise your hand or ask in the chat.
Hi, Karan. Sanket here. Actually, I want to ask how the green-blue deployments work in GKE right here. Yeah.
Okay, so you can do blue-green deployments in Cloud Run as well as